for Solar Eclipse. My name is Brooke Steele. I am a general studies freshman and I will be a moderator today. Before we get started, could everyone please make sure that you scan one of these QR codes around the room. This is how your professors are going to make sure that you attend and get your extra credit, and also this will enter you into the STEM raffle. Now allow me to please introduce you, our presenter, Dr. David Simpson, and tell you a little bit more about him. Dr. David Simpson received his Ph.D. in physics from Virginia Tech. He also received his MS degree in applied physics and applied mathematics from Johns Hopkins. He has a Ph.D. in applied physics, an MS in aeronautical and astronautical engineering from Purdue. And he is currently completing an MS in applied space weather research from Catholic University. He began his career at ComSat Laboratories before working at the NASA Goddard Space Flight Center, where he had worked on flight software for the onboard computers of several spacecraft, including the Hubble Space Telescope. He has also done space gravity physics research with the Image and Cassini missions and has been involved in a number of other NASA projects, including CubeSats, quantum computing, near-Earth asteroid research, solar corona computer modeling, and spacecraft magnitude calibration. Dr. Simpson is a fluent speaker of Esperanto and sings second bass in his church choir. He has been an adjunct professor of physics at Prince George's Community College since 1991. I'd also like to give a welcome to Dr. Calvin Stansbury, the Dean of STEM Division, and Dr. Thomas Simon, the Chair of Natural Sciences. Now, please welcome our presenter, Dr. David Simpson.
Well, thank you very much. We've got a very interesting astronomical event coming up here shortly. I asked some other people at NASA if they would be willing to give the talk, but they're all in Texas for the eclipse. So I happen to still be in town. I'm going to be leaving on Friday to go to Texas to go to see this, and I'll show you why Texas in a little while. But the event, of course, is the total eclipse of the sun coming up on April 8th. That's Monday of next week. And these don't happen very often, so it's especially they don't happen very often in North America where we can see them within driving distance. So it's quite an extraordinary event, and we're going to hope to get some good science out of this. Well, just some brief background here, a little bit on the phases of the moon. If you imagine the sun is over here to your right, and the Earth is there in the center. You can see kind of what these phases of the moon look like and where the moon is with respect to the Earth, looking down onto the Earth's North Pole. You see that if we've got the moon and the sun kind of in the same direction, that's called new moon. And when they're in opposite directions, so that the moon is fully illuminated, that's called full moon. Halfway between new moon and full moon is the first quarter. The phases go in time this way, counterclockwise. So we have first quarter and then full moon and then third quarter. And here waxing means increasing and waning means decreasing. Crescent moon and gibbous moon. Those will be important when we talk about eclipses. So that's just kind of some general nomenclature. I don't know why it's called quarters. There's no half moon. Like first quarter, third quarter, and full moon. Also, don't use the term dark side of the moon. There's no such thing as that. It's the far side of them. The moon is such that it always keeps the same face pointing toward the Earth, and the face that's always away from the Earth is called the far side. Okay, two kinds of eclipses that we have as seen from the Earth. A lunar eclipse occurs when the Earth comes between the moon and the sun, so that it's the Earth's shadow falling on the moon, causing the moon to turn kind of dark. And it doesn't go black, it's kind of a reddish color because of refraction of the light through the atmosphere. And a lunar eclipse can only happen during a full moon. So you'll see the entire lunar disk illuminated, then it goes dark for some period of time. A solar eclipse, which is what we've got coming up now, is that occurs when the moon comes between the Earth and the sun. So it's the moon's shadow falling on the surface of the Earth. And that can only happen during a new moon. And what happens is the moon kind of comes between the Earth and the sun, so we see the moon blocking out the sun, and it gets dark. That's a solar eclipse. That's what it's coming up Monday. There are several types of solar eclipses. This is the partial eclipse. That's what we're going to see here in Largo. If you don't go anywhere else for the eclipse, you're going to see something like that, where you're not in the total eclipse zone. That's further to the west of us. If you want to see the solar eclipse, it's probably up to Cleveland would be the nearest place to see it. But we're not in the eclipse zone here, so we're going to see a partial eclipse here in Largo. We're not going to see this. That's an annular eclipse. That happens if the moon is farther away than it is going to be on Tuesday, so that it doesn't entirely block out the sun. And then what we are going to have, if you're in that total eclipse zone further to the west, is this total eclipse, where the moon is big enough that it completely blocks out the sun. And I'll talk about the details of this in a minute, why that happens that way. Okay, the sun has an atmosphere of sorts. Instead of a gas, it's a plasma, but it consists of 3 layers. There's the photosphere, is kind of the bright, visible, what we would see as the surface of the sun, and that's what's the bright part of it. Just above that is something called the chromosphere. That's a kind of a reddish layer that you may be able to spot during the eclipse. It's kind of a reddish due to the hydrogen that's present. And you will definitely be able to see, if you're in the total eclipse zone, this thing called the corona, which is an extended layer of plasma that's up above the chromosphere and extending outward. But during the total eclipse, the moon will block out the bright photosphere and allow us to see the corona directly. So we can't normally see the corona because it's too dim compared to the photosphere. But during an eclipse, the moon blocks out the photosphere, and so you can see the corona. And it's quite a sight, actually. Well, solar eclipses rely on a really remarkable coincidence. It just so happens that the angular size of the sun in the sky is almost exactly equal to the angular size of the moon. Of course, the sun is much, much bigger, but it's also much farther away. The moon is closer, but it's smaller in diameter. And it just happens that things work out that they're almost exactly the same size. And that's what allows us to see a total solar eclipse. If it weren't for that particular coincidence, we'd have no chance. And just to give you an idea of a rough calculation, the angular diameter of the sun would be the sun's diameter divided by its distance from the Earth, works out to be 0.533 degrees on average. The moon's angular diameter is the diameter of the moon divided by how far away it is, and that comes out to be almost the same thing, 0.518. But these are just averages. If those were constants, then the sun, the moon would always be bigger than the sun. You'd always have an angular eclipse. But it turns out that the orbit of the Earth around the sun has some eccentricity to it. It's not a circle, it's kind of a flattened circle, so it's an ellipse. And so is, and to a greater extent, the orbit of the moon around the Earth, also an ellipse. And that means that the distance between the Earth and the moon is constantly changing, as is the difference between the Earth and the sun. When you're at the diagram here, let's say this is the orbit of the, no, that won't make it onto the recording, but let's say this ellipse is the orbit of the, let's say, the moon around the Earth. The Earth will be at one of the 2 foci of the ellipse. And if you're here, this is the moon at perigee, and over here, the moon is at apogee. So you can have the moon closer to the Earth or farther from the Earth. When it's closer, it looks bigger. When it's further away, it looks smaller. And so there's some variation in the angular diameter of the sun and the moon as observed from the Earth. And actually, if you go to see the eclipse, that's what it's going to look like. You'll see this is black circle in the middle is the moon, behind it is the sun, and this thing around the edges is the corona. Well, here's more on that coincidence. The sun, the apparent size of the sun varies a bit from 0.525 degrees to 0.542 degrees. The smaller circle there represents when the Earth is at aphelion, and the larger circle is when it's at perihelion. So the smaller circle is when we're farther from the sun and the large circles funnel closer to the sun. The moon is in a more eccentric orbit, so there's a bigger variation there, but you see the moon can appear anywhere from 0.493 degrees to 0.554 degrees. This is when it's at apogee, the furthest from the Earth. This is perigee, closer to the Earth. And you can see there's overlap. In fact, all of the possible range of diameters of the sun fall within the range of diameters of the moon. So you can have kind of anything happen. A total eclipse, an annular eclipse, depending on where the moon is in its orbit at the time of the eclipse. If you get a total eclipse of the size of the moon, of course, it's greater than the size of the sun. For the eclipse coming up, the sun will be at 0.532 degrees, the moon at 0.554 degrees, so the moon will be bigger than the sun. We get a total eclipse if you're in the right spot. As a matter of fact, the moon will be at perigee, its closest point to the Earth, like 25 hours before the eclipse. So we're going to get a really big, relatively large moon, because it's going to be very close to the Earth. It's going to be almost as close as it can be. So we're going to have to get the moon will be almost as big as it could possibly be, covering up the sun. So we'll get a very nice view of the eclipse. Eclipses do not happen every new moon because there is also an inclination to the moon's orbit. Besides being elliptical, it's also tilted with respect to the ecliptic plane, the plane of the Earth's orbit. And so you can have a new moon where the moon is down here and the shadow goes up above the North Pole, or the shadow goes down below the South Pole, and you don't get an eclipse in the case. You have to have a new moon at the time when the moon is kind of in the ecliptic plane, and that happens in what we call eclipse season around the time of the equinoxes. So around the spring or the fall is when you're going to see a total eclipse. And here we are near the vernal equinox, which was like the beginning of spring, March 25th. That's why we're able to see a total eclipse. So you see it either in the spring or the fall. The moon will be positioned such that its shadow will end up on the surface of the Earth. There are typically between 2 and 5 solar eclipses each year, with a total eclipse taking place every 18 months or so on average. But you may have to do quite a bit of traveling if you want to see these things. And people do that. They have total eclipse cruises where you can get on a ship and go out in the middle of the ocean to watch the eclipse. Total solar eclipses as seen on any particular spot on the Earth, like Largo. We'll see one here in Largo about every 400 years. I don't know when the next one's going to be. I didn't look that up. I mentioned this coincidence that the moon happens to be just about exactly the same size as the Earth to allow these total eclipses to happen. Well, it's even a bigger coincidence because the moon is gradually receding from the Earth due to tidal friction. The moon causes tides on the Earth. That causes the Earth to slow down its spin. And to conserve angular momentum, the moon moves away from the Earth very slowly. So in the distant future, I'm guessing millions of years time frame, the moon will have moved far enough away from the Earth that we won't see total eclipses anymore. And on the other side of the coin, dinosaurs probably saw a lot more total eclipses than we do today, because the moon will have been closer 100 million years ago. How do you view the solar eclipse? Well, you can use eclipse glasses. That's very nice. And if you don't have any, I've got a big supply of them on the cart up here. You can pick those up on the way out. Be sure they're ISO certified. All the ones on the cart there are ISO certified, ISO 12312-2. Certified for direct solar viewing. But before you use them, you should inspect them, make sure they don't have any holes punched in them or they're not scratched or anything like that. Make sure they're good. If you see defects in them, don't risk your vision. Just kind of throw them out and get a new pair. There's also a possibility of doing a pinhole projection where you could take a piece of cardboard, poke a little hole in it, and project it onto the sidewalk or onto a screen and see it that way. Or just the last option would be NASA TV. If you can't get outside for some reason, it's going to be covered live on NASA TV. And they'll be in the total eclipse zone where you'll be able to watch the total eclipse. I remember there was a total eclipse of the sun back in like 1970. I remember it was on TV. My mom got such a big kick out of the way they covered it. The total eclipse of the sun, brought to you by Gulf. Gulf Oil Company did not bring us the eclipse. And here's some other ways to see it. This is some pictures I took back in 2004, 2012 of the transit of Venus. And what I did here is I got a 6-inch reflecting telescope. I put an eyepiece in it, just like you were going to observe the stars, only there's also a projection screen up behind that. And so it goes through the telescope, projects onto the screen, and there's the sun, and there's Venus right there. Transits of Venus across the sun are very, very rare events. I think the next one's going to be in 22 something, they're hundreds of years apart. So we were lucky to get to see it in this century. This is a sun spotter. It's specially designed to be a telescope, the small telescope of the sun. The whole thing's not that big. The sun goes through the circle there, reflects off a mirror, and you can see an image. There, and there's a solar telescope where you, even during when it's not during an eclipse, you can look through the telescope and see the surface of the sun in the hydrogen alpha line. So all kinds of ways to see the eclipse. The direct viewing through the eclipse glasses over there is probably the easiest way. And I have to put some caveats here about viewing safety, because we always have to do this. I know you've heard this all your life, but we want to say it again anyway. Do not look at the sun with the naked eye. That'll really do bad things to your eye. In fact, with this telescope, here I was doing a solar, showing the sun at work one time, and I just demonstrated how dangerous this was. I took a leaf, held it up to the eyepiece, and burst into flames. So you don't want to have your eye up on that eyepiece. Projecting it is okay, but you better really be careful if you're going to look directly at the sun.
That's the question.
Huh?
So we should not look at the sun with naked eyes, but during a total solar eclipse, should we continue to stare at it because it's very small? Should we stare at the total solar eclipse with naked eye?
Only if you're in the zone of totality and the moon has covered up the entire sun, then it's safe to look at the corona.
When it starts even moving away slightly, the moon in front of
As
us.
soon as you see the first little speck of bright light appear off the limb of the sun, the moon, it's time to stop looking at it. Yeah. Do not look at the sun through binoculars or through a telescope unless you are absolutely certain that you've got the correct solar filters put on those things and you know what you're doing. As you look at the sun through some binoculars, your eyeballs are going to catch on fire. You don't want that. It's not worth it. Do not use ordinary sunglasses to look at the sun. I know they're called sunglasses, but they're not good for looking at the sun. They're good for blocking out glare and polarized light, things like that. But you can't look at the sun through sunglasses. And do not try to improvise your own direct viewing device. You may say, hey, I do welding at home. I've got a welder's mask. That seems like that ought to be pretty good. No, don't do that. The eclipse glasses are especially made to block out not only the bright visible light, but also the bright invisible light, the ultraviolet and the infrared that can also cause eye damage. So don't try to improvise something. Get something especially made for direct viewing of the sun. Or you can cause permanent eye damage or even blindness. So really be careful with that. These are fine. Just make sure they're not damaged and they'll work fine. In fact, if you look through these, when you pick one on the way out, you'll notice you can't see anything through them. You won't be able to see anything except for the sun. Only the sun is bright enough to get through all the layers of filtering. And finally, it is safe to remove the eclipse glasses and look at the sun directly only if you're in the zone of totality and only during the total eclipse. So once the moon is completely covered up, then you can take off the glasses and go, whoa, look at the corona. And you're going to see, with the naked eye, you'll see that. And seeing a picture of it and seeing it in real life is a whole different experience. And don't spend the whole time with your camera taking pictures of it. You can get pictures off the internet. Just take some time to appreciate it. Look at it. I remember looking up at the one last time in Tennessee. Whoa, you can't believe what you're seeing. So put the cell phone down, put the cameras down, just enjoy it and appreciate it. It doesn't last very long, just a few minutes. Okay, so that's viewing safety, be sure you observe that. Don't risk your vision on this. Be sure you are using safe eclipse glasses or projecting the image. Okay, in particular about this eclipse, the eclipse will be Monday, April 8th, 2024, and will be an especially interesting one. As I mentioned, the perigee for the moon's closest point to the Earth will be the day before, April 7th at 1:52 p.m. It's 25 hours before the eclipse, so it's going to be an unusually large moon covering the sun, which means a particularly long time of totality, as much as 4.5 minutes. Is quite a long time for a eclipse. Several large cities will be in the path of totality: Austin, Dallas, Indianapolis, Cleveland, Buffalo, Pittsburgh. Of those, probably Cleveland is probably the closest to here. So if you haven't made plans, you could hop in the car at the last minute, drive to Cleveland, and go to see it. But there's probably going to be a lot of traffic of people trying to get to the eclipse zone, so take that into account. Go to the zone of totality if you can, if you get a chance to see this. It's like you don't get to see this kind of thing very often. And I can tell you that a total eclipse is a completely different experience from a 99.9% eclipse. It's just a whole different thing. It's not even close. So if you can get a chance to see the actual total eclipse, and don't settle for 99.9%, see the total eclipse. It's a whole different experience. This is the zone, I mentioned this zone of totality, and there it is, that black band here. The eclipse path will go from the southwest up to the northeast. I'm going to be over here in San Antonio, which is right at the edge of the zone of totality, so I plan to stay there and then drive over the rest of the way into the middle of the eclipse zone to get the maximum eclipse. And move up here. It barely clips off just a few feet of Tennessee up there. It's up near the Kentucky Bend. And goes up here, Ohio, up into New England and Canada. It'll start with Mexico going up to and we're, of course, outside the zone of totality, we're over here. So you could drive to a place. Notice the web site down at the bottom. You can take a picture of that and look at it later and blow it up, and you can see all the details. There are a lot of details of information on this. There's these diagonal lines here are an indication of what percentage of the solar disk will be covered in that sort of here. There is indications of when the eclipse is going to be, how long. There are horizontal lines going, or diagonal lines going through here to tell you the duration you can expect of the eclipse. The closer you are to the center of the totality zone, the more the eclipse you'll see, the longer the eclipse will be. What about weather? What if I drive all the way to Cleveland and it's covered with clouds? Well, that's what this map is for. I wanted to plan to see where should I go to see this. And I found this map. It's a cloud cover climatology, showing you kind of where you're going to get better odds of clear skies. And generally, the further to the southwest you are, the better chance of clear skies, and increasing chance of cloudiness as you go up to the northeast. So that's why a lot of people are going to Texas to see it. It's also the shadow is going faster as it goes up this way, so the eclipse duration gets shorter and shorter as you go to the northeast. So down here you have longer eclipse duration and also a better chance of clear skies. So a lot of people are going to be in Texas. In fact, I made like a month ago, I made a reservation to go to San Antonio. Got my hotel room. I have to rent a car. There's no cars. Rental cars in San Antonio. So I'm going to have to fly into Houston and then drive a couple of hours to get to San Antonio, because Houston's the only place I can find a car. Because everybody's renting them that's going down there to watch the eclipse. But that's going to be the place to be. If you're here in Largo, you will still be able to see a partial eclipse. It won't be as spectacular, but you'll see something. You'll be able to see anywhere in the continental United States. You'll be able to see something, and this is what we're going to see in Largo. The eclipse beginning at 2:04 p.m., ending at 4:33 p.m. with a maximum at 3:20 p.m. And at the maximum, you're going to see something like this. You'll see a little crescent sun, mostly covered by the moon. And you would think, oh, it's going to be dark. I'm going to need a flashlight. No, actually, surprisingly, it's going to be almost as bright as if there were no eclipse at all. In fact, even more of the sun getting eclipsed. So you just have a teeny sliver of sunlight left, and it's still as bright as a normal day. You don't really notice any difference until that last teeny little sliver of the sun disappears. Then it suddenly gets dark. And you wouldn't expect that. You think it would gradually get dark, but it's bright, it's bright, it's bright, it's bright. And suddenly the last little bit of sun gets covered up and it's dark. It's really surprising. You wouldn't expect that. So it's not going to be very dark with this kind of coverage, but you'll be able to see the partial eclipse anyway. And some things to notice while you're there. I just mentioned the illumination. You won't see much of a change in the ambient light level until, well, you won't see it at all here. You won't really notice much of a change. But if you're in the zone of totality, you won't notice any change until just an instant before totality. And then it'll suddenly, it's like turning on a light switch. It'll go from, over the course of a minute or so, it'll go from suddenly bright to dark. The temperature, one thing you notice is the temperature suddenly drops. The sun gets covered up and suddenly it starts getting cold. And you wouldn't expect that just in a couple of minutes, but yeah, the temperature drops noticeably. And in fact, I'm going to try to take some equipment with me, and I want to do some measurements to see if I can make a plot of temperature versus time as that goes on, to see just the extent of that temperature change and how quickly it happens. Sounds, besides the sounds of the crowd and the people oohing and awing around you, listen for the animals, like especially birds. Birds get confused. They see the light, the sun has gone away, and they start chirping like they would in the early morning. They're not really sure what's going on. You'll hear maybe crickets will start to come out. So it's really interesting just to hear the response of the animals, the wildlife around you to the eclipse, because it's not something they're used to. And crescents, you will see, even when the eclipse is partial, even if you're here in Largo, during that partial eclipse, you'll be able to see crescents everywhere. Light will be shining through the leaves of the trees, and look on the sidewalk, there are all these little crescents everywhere. And if there are no trees nearby, just go out and with your fingers, kind of spread apart like that, just hold them like that. You can make little gaps between your fingers and hold them out like that. You'll be able to see between your fingers little crescents on the sidewalk. They look like little crescent moons. They're crescent suns, but there's crescents everywhere. Where light has to filter through tree leaves or through your fingers, you'll just see all these crescents everywhere. It's really kind of neat. Features you may see during the eclipse, if you're in the totality zone, is the chromosphere. As the moon covers the sun, you may be able to see, the moon might be a little close for this time, but you may be able to see a reddish ring around the base of the corona, and that is the chromosphere. The chromosphere, remember, is the layer of the atmosphere between the surface of the sun, that's the photosphere. Right above the photosphere is the chromosphere. It's kind of a reddish color, and you may be able to see that during a total eclipse. There's something called a diamond ring effect, where just as the last bit of sun is getting covered, that last bit of sun will make the whole thing look like a diamond shining, and you'll see a ring around there, look like a diamond ring. It's called the diamond ring effect. When you get just the last bright point of light is just about to be covered up. There's something called Bailey's beads, and that has to do with the moon is not just a smooth. It's like a pool ball. It's got terrain on it. It's got mountains and valleys and things. And this Bailey's bead effect is due to the sunlight passing through gaps in the moon's terrain, between the mountains and things like that. You'll see little patches of little bright spots around the edge just before totality. And that's due to the terrain on the moon. And prominences, you may see coming off of the disk of the sun, like loops of plasma. Those are called prominences. It's just the plasma on the sun following the sun's magnetic field, and they go into loops. Well, something about eclipse science. A solar eclipse provides us with a rare opportunity to collect information about the sun and its interaction with the Earth. Now, it's true that we do have spacecraft and other, maybe some ground-based telescopes that have something on them called a coronagraph. And you build kind of a telescope and you put an occulting disk in there, and you can block out the photosphere and see the corona. So you can study the corona at any time. The problem is that it's kind of difficult to block out just the photosphere. You have to block out the photosphere with the occulting disk and then some space beyond that. I'm not entirely sure why that is. I suspect it has to do with diffraction of the light around the occulting disk. But you can't use a coronagraph to study the lower corona. And that's something we're really kind of interested in is how does the corona work? Why is it as hot as it is? Nobody can really explain why it is as hot as it is. And trying to understand the mechanisms behind that and the interaction between the lower corona and the middle corona, details of that you can really only observe during an eclipse because the coronagraph does not let you see the lower corona. You really need an eclipse to be able to see that. So people are pretty excited to have this opportunity to go do this kind of science. Also, the coronagraph will not let you study the response of the Earth's atmosphere to the blocking off of the sunlight. You can only do that with an eclipse. And that's something else people are interested in, is people who study the Earth's atmosphere and the ionosphere. They're interested in what happens if you suddenly turn the sun off in this little region. How does the ionosphere respond to that? How quickly does that response happen? And so that'll be a lot of people interested in the ionosphere's response to the eclipse. And so it's going to be a object of a great deal of study. And that's something, again, you can't do with a coronagraph. You need a real eclipse to see how the atmosphere is going to respond to the sun being turned off. Historical eclipse science. I mentioned that the moon causes the tides in the ocean, and the tides produce a tidal friction on the moon that cause the moon to cause the Earth to gradually slow its rotation over time. And to conserve angular momentum, the moon moves away from the Earth at the same time. Once in a while, you hear something about a leap second. I don't know if anybody's ever heard of that. You'll hear it on the news, something about a leap second. Well, it's because the Earth is gradually slowing over time. It's related to that. And so in order to keep our atomic clocks in sync with the Earth's rotation, from time to time, we have to introduce a new second, an extra second into the day. You'll have at the end of the day, it'll be 11:59:58, 11:59:59, 11:59:60, and midnight. The 11:59:60 is the leap second. And on average, about every year and a half that happens, but it's been a couple of 3 years, I guess, at least, since we've had a leap second. But historically, this has allowed us to determine the rate at which this slowing has happened. Because you can do celestial mechanics calculations, you can predict when past eclipses would have been. And you'll predict, so here's when the eclipse path should have been, and they should have been able to see an eclipse in these cities right here. But you find out, if you go back to the historical records, you saw that it was over in these cities where they saw the eclipse. So the Earth's rotation can't be, you must have had the Earth's rotation rate wrong in there. So you adjust the Earth's rotation rate so that the cities where the eclipse was recorded to have been observed match up with your celestial mechanics calculations. And then you can, from that, infer the change in the rate of the Earth's rotation. And that's how we know this kind of thing, that the Earth has been slowly, its rotation rate has been slowing over time. We know that from these comparing historical eclipse records with celestial mechanics calculations. Also, the element helium was first discovered in the solar corona during a solar eclipse. Somebody took some spectra back in 1868 of the solar corona during a solar eclipse and discovered there were spectral lines there that were present that hadn't been seen in terrestrial elements before. And so they named this new element helium, helios being Greek for the sun. So that's why it was called that, because it was first discovered in the sun. Also, general relativity. Albert Einstein published his general theory of relativity in 1915. That's his theory of gravity. It's still, to date, our best theory of gravity. And one of the predictions of general relativity was that light is bent by gravity. And that could be tested during a solar eclipse just by observing the positions of the stars near the limb of the sun. If you remember your history, you might be able to guess why they weren't able to test this right away. 1915? What was going on in 1915? World War I. So people were not fond of the idea of, oh, there's going to be a total eclipse in South America. I'm just going to load up all my equipment onto a ship and take it across the Atlantic. No, the Atlantic Ocean is being patrolled by German U-boats. You don't really want to have your solar eclipse scientific expedition torpedoed by a German U-boat. So they had to wait until World War I was over. That was November 11th, 1918. So after 1918, I think they had a couple of attempts to observe a total solar eclipse that were thwarted by weather. You get there, no satellite pictures of the Earth to look at. So you get to your eclipse zone, you set everything up, and there's clouds. So you're out of luck. But finally, on May 29th, 1919, there was a total eclipse that was going across South America and across Africa. They sent expeditions to both places and were able to do the observations. And the idea is that if general relativity is correct, then the sun's gravity should be able to bend light. And so if you look at stars near the limb of the sun during the eclipse, you should see their positions shifted relative to where you would expect them to be, right? Because the light is being bent as it goes around the sun. And sure enough, they did the observations, and sure enough, the positions of the stars were displaced from where you would expect them to be, and the displacement was consistent with the predictions of general relativity. So kind of interesting, we had to wait from general relativity was developed in 1915. World War I was already going on by then. They had to wait till the war was over, but before they could have an expedition to go see the solar eclipse and verify it. What about this eclipse? We've got a number of scientific investigations being planned for this eclipse, done by NASA and other organizations, the universities, anybody who's interested in space weather or the sun. Space weather, by the way, is it's kind of looking at the space environment as if it were kind of analogous to terrestrial weather. There's you get storms, you get eruptions happening on the sun that cause plasma to stream toward the Earth. You can get magnetic storms on the Earth. If they're strong enough, they can knock out the power grid. And in fact, there was one famous case back in 1859 called the Carrington event, where a really, really strong eruption on the sun sent plasma toward the Earth. 1859, right? We don't have the internet or anything in 1859, but we did have telegraphs. And it kind of knocked out, did all kinds of weird things with the telegraph lines. They either knocked out the telegraph lines or the telegraphs would run by themselves without batteries. There were fires started and things like that. So people are really concerned about what would happen if there were a Carrington strength event today. What would happen to us? And that's one of the big objectives of space weather research, is to understand enough about the space weather system to be able to predict this kind of thing ahead of time, so that if we see some huge storm coming toward the Earth, we're not going to end up back in the Middle Ages. We'll take the power grid all offline, wait for the storm to pass, and then we'll put it back. So that's one of the big reasons there's so much interest in space weather and the heliosphere, the Earth and the sun and the plasma and the magnetic fields that connect them, is to try to prepare for that kind of event. And eventually something like that will happen. It's just we don't know when. The last time was 1859. It could happen anytime. So we want to be ready for that. Again, I mentioned the investigations into the interaction between the lower and the middle corona, hoping you get some insights into the origin of the solar wind and the coronal heating, and just how in general that corona works. Because there's the corona is much hotter than we would expect it to be, and we don't really understand where that heat is coming from, how that heat is generated. And hopefully this kind of thing, getting some glimpses into the lower corona, will allow us to get some insight into that, understanding that problem. Ionosphere investigations are also very important, learning about the general effects of the eclipse on ion recombination and the general response of the ionosphere to the sudden disappearance of the sun for a few minutes. You can make contributions to this yourself if you want. There's several citizen science efforts. If you're interested, you can go to this website. They have a list of all the things going on. This includes recording images, recording sounds, recording temperatures. I guess I'm not registered for this, but I'm planning on doing a couple of those. And if you have a radio, you can help with radio propagation studies. People are going to be interested to see what happens with radio when the sun is turned off during the eclipse zone. And if you have a ham radio license, they've got people participating in trying to do two-way contacts, trying to talk to each other through the eclipse zone to see kind of how that affects the ionosphere, because the ionosphere is responsible for a lot of the reflection of radio waves and radio propagation. And here's some more information. This is here's our primary NASA site about the eclipses. There's a website called greatamericaneclipse.com. If you get a chance to see that, that's really interesting because they've got an animation that shows it's kind of like a camera looking down on the eclipse zone, and it's following the eclipse zone as it goes across the United States. You see the different cities go by, and it shows the speed of the eclipse area, and it goes faster and faster and faster as you go up toward New England. So that's a really interesting animation to see. If you're interested in citizen science and maybe doing some science to help contribute to that, there's a citizen science link. There is a live stream app you can get downloaded on your cell phone to watch it in live stream, and this is some information that I had on the timeanddate.com that let me put some of this information down here about what's going to happen here in Largo. So if you live somewhere else, you can go to that timeanddate.com and put in your city and to get detailed times about when to expect the eclipse. But I guess that's it. So if you have any questions, I'll be glad to answer them. Thank you. Yes.
Why does hydrogen gas create a reddish color?
It's sunlight hits the gas. It kind of excites the electrons into a high energy state. When the electrons decay back again, that difference in energy levels happens to be in the red part of the spectrum, and that's why. Actually, every element, including hydrogen, will have a characteristic set of spectral lines in it that are kind of a fingerprint of that element, and hydrogen is kind of the dominant. It has a reddish line in it. No.
Dr. Simpson, I want to mention that some people from JPL are attending on Zoom.
Oh, okay. Well, I hope I did a good enough job here.
Are there certain locations that are more likely to experience eclipses than any other place?
We didn't
Could you repeat
understand
the
the
question?
question.
Oh, yeah. Are there any locations in the world that are more likely to experience a total eclipse than other places?
That's a good question. I don't know the answer to that. No, I wish I did, because I think one of the upcoming solar eclipses is going to be up around Canada, around the North Pole, Iceland, and you have to go up there to see it. So they do happen near the poles. I don't know if near the equator is more likely than near the poles or not. So I don't know the answer to that. That's an interesting question.
Would you say a student should, if they have the opportunity, go to somewhere where there's eclipses, like right now?
I would say if you can manage to do it, yeah, definitely. It's something you want to see at least once in your lifetime. He's asking if we should go see the total eclipse if you can. Yeah, definitely. If you have the opportunity to do it, and if you're willing to drive as far as Cleveland to see it, which I've done. It's like an 8-hour trip or something. I've done it not too long ago, but yeah, it's certainly once if you get a chance to see that at least once in your lifetime, it's worth seeing. And I think it's going to be about 20 years before there's another one in North America.
I may mention one thing for the whole audience. As you heard, Dr. Simpson has brought some eclipse classes, and NASA has given us eclipse classes for students. So even if you don't go to see a total solar eclipse, on the day of the eclipse, we will have an event here where students can watch together, okay? So please remember to come here. Thank you, Dr. Simpson, for being
Oh,
with
good.
us.
Yeah, I remembered in the 2017 eclipse, we had, that one was going from the northwest down to the southeast. And there was a big shortage of eclipse classes back then. They were really hard to find. So I wanted to grab up a bunch of them and now they're relatively easy to find. So, but yeah, be sure to help yourself to eclipse classes on your way out.
So, let me say thank you for one more presentation. My question has to do with one of the earlier slides that you had about every 400 years. And I was wondering, was that every 400 years, you talking about the eclipse, was that based on the zone of totality? Is there a connection there?
I don't know how they computed that, but the idea is that if you pick any spot on the Earth, like Largo, there will be an average of about 400 years between total eclipses that you will see at that spot. So if I stay here in Largo, it's going to be like a total eclipse in Largo. It'll be 400 years before the next total eclipse in Largo.
Thank you.
Thank you so much for this presentation. What I really appreciated even more is we talked about the effects on what we have, what we see at space weather, because most of the times people think that it is just that we are seeing the sun as a dark spot. They don't realize the implication of its activities on us. And the space weather, like in today's technology era, we cannot imagine life without the cell phone and how the space weather can affect shutting down electricity like it did in Canada a few years ago and so on. So thank you so much for touching on those points. And this is a lucrative career. Students, please ask questions. This is a great opportunity for you all to ask questions, okay? I am asking some questions.
I just have a comment. So when you talk about the physical, are the atmospheric changes, are things moving without reason, it made me think about ghosts and poltergeists. You know, just science fiction, what we would call science fiction, but there may be explanations or associations. So it was just a comment. I know I mentioned it here.
Yeah, it's as the sun gets covered up by the disk, then suddenly parts of the ionosphere that are normally, have ionization going on, and now suddenly the molecules can go recombine. And so kind of learning something about that process when it happens suddenly and just for a few minutes is really going to be interesting for ionospheric researchers. So, yes.
You said that you were gonna bring equipment to see the changing in temperature. Will you post those findings anywhere or just for you?
I'm thinking I'll probably put them somewhere. I'm not sure. Maybe on my personal website or maybe up on archive.org or something like that. There's a place called arxiv.org where people can put all kinds of papers that they might have a kind of a problem publishing otherwise. No, my dad and I put a paper up there a couple of years ago. We got interested in the problem of determining the mass of the atmosphere. And we were going to publish it, but you need reviewers to review the paper, and there weren't enough people in the world working on that problem to find reviewers. So we put it up on this called arxiv.org. And you can put papers like that. A lot of times it's pre-prints of things that are going to be published, but sometimes it's things that just don't have a home to get published elsewhere that people put up there. So maybe I'll put it up on arxiv.org. I'll be kind of interested to see how quickly the temperature changes and how much it changes. Oh,
Someone in the chat asked if they can look at the eclipse through a mirror or can they make their own eclipse seeing device?
you can go on the internet and find instructions for, in fact, I think one of these links up here has, I think it's one of these associated with NASA up there. Maybe this first link had some instructions on how to make your own eclipse observing equipment with like a mirror, and they have something called an eclipse box. You take a big box of Rice Krispies or something and you eat the Rice Krispies out of it, and then you got the box left over, or you make Rice Krispies treats, whatever you do. You have the box left over, you cut a hole in it and put a pinhole in there and and maybe a mirror, and it's a projection apparatus where you can look through the box to block out all the ambient light. And then you can see a projected image of the sun in there. So look on the internet for instructions on how to build that kind of thing. I would tend to go with reliable sources like NASA to tell you how to build it right. Otherwise, if you don't want to risk your sight, losing your sight from somebody who doesn't know what they're talking about. So go to a university or to NASA or someplace for instructions how to build one of those. Yes.
You mentioned things like temperature and animals sensing the eclipse and thinking it's nighttime and they have an effect on them. What are other things that are affected that we can't see, or things that we don't actively think about during a total solar eclipse?
The things I mentioned were the things that came to mind. Again, can't think of anything else right off hand. I know people were concerned about traffic. People are going to be in their car, driving through the eclipse zone, and suddenly it's a total eclipse. Whoa, look at that! And crash. So there are warning people that in the eclipse zone to be careful about driving during the eclipse, because there are going to be people watching the eclipse. They're not going to be watching where they're going. So other than that, effects, I can't really think of anything else that I didn't mention before. I'm sure there's other things I'm just not thinking of them.
Well, like, does it have a direct effect on gravity or the gravitational pull of the moon? Say like with the waves, or how the winds of the earth are controlled?
It may have an effect on the winds just because of the heating. The gravity would not be affected any more than it would be during any other new moon. So that, the tides would be the same as they would be during any other tide caused by the moon and the earth being lined up. Oh,
In those states where it's supposed to be fully dark, do you think it's gonna be like a lot of crime over there? Or it's gonna be totally dark?
the question is, will there be a lot of crime during the eclipse? I don't think so, because it's only going to be about 5 minutes. And while it's dark, people are going to be looking at the eclipse. They're not going to be out robbing banks or that kind of thing. It's not going to be dark enough for long enough for anybody to take any nefarious advantage of it.
I know that it's only gonna be dark for roughly 5 minutes, but would it be dark for long enough for say for you to be able to see a horizon star?
Yeah, actually, that's a good point. I didn't mention that, but yeah, it probably will be during totality. If you're in the totality zone, dark enough to at least see brighter stars. I think the one I saw in Tennessee, 2017. I think I did see some stars out. So yeah, it will be dark enough to see that. If you're driving, you'll have to turn your headlights on, but most people aren't going to be driving. They're going to be watching the eclipse. Yeah, in the back.
So what would it look like if the moon was like, because you showed the angle? What if the moon was bigger than the sun? What would it look like?
In that case, you would not get as nice a view. You wouldn't be able to see the corona as well, because maybe it would cover up the whole. If the moon were much closer, it would just cover up the whole corona, and you wouldn't be able to get that kind of a view. That's kind of what happens with a lunar eclipse: is the Earth's shadow is cast on the moon, and the moon is just in a shadow for a long time. So it's really a weird and very fortunate circumstance that they just happen to be so close together in size that the moon gets in front of the sun, and you can see all the way around the moon and see the corona. It's a really remarkable coincidence that we really lucked out there. Yes.
Would marine life be affected by the eclipse as well?
I'm sorry, what kind of?
Marine life?
Oh, marine life. I had never thought about the effect of marine life. I think after it leaves New England and going up to Canada, this will start to go over the Atlantic. Certainly deep sea marine life will probably not be affected because there's no sunlight getting that far anyway. But up in the upper layers of the ocean, where sunlight normally does get through, yeah, it's possible some marine life is going to get kind of confused. I don't know if anybody has studied that or not, but that's a very interesting question to see if they get as confused as the birds and insects seem to be during a land eclipse. But yeah, interesting question. Don't know the answer to that. Yes.
So you mentioned the angular diameter and how to calculate it. Can you explain what exactly the angular diameter is?
If like this is the sun, whoops. No, that's not gonna work. If the sun is like this, it's kind of the angle from your eye out to where the sun is. So imagine a kind of a triangle where the sun is the base and then the vertex is up where your eye is. So it's that vertex angle is the sun. That's the angular diameter of the sun or the moon. Yeah.
It's my hair.
Oh, thanks.
It's very good.
You needed a piece of chalk.
Oh.
Or eraser.
Yeah, chalk never did that. Yeah, so it's kind of this angle. In the back?
So, you referenced how like, you know, the dinosaurs was like back in the day, they had like a better use experience than we are. Like, so would you say like in a couple million years, like, what we wouldn't see like, you know, a really good.
It's going to take a long time, but eventually I expect the Earth is going to get far enough away from the moon. Will get far enough away from the Earth that total eclipses will become rarer and rarer, and eventually you won't have them at all. You'll only have annular eclipses once the moon gets far enough away. So we're not only fortunate to have this coincidence where the Earth and the sun have the same angular diameter or the same size in the sky, but we also happen to be living during the period when that's true, when you can see that eclipse. If we were millions of years in the future, you may not be able to do that because the moon would be too far away. I mentioned the moon is tidally locked to the Earth. That means we always see the same face of the moon as seen from the Earth. We never see the far side of it. It also means that if you were on the moon, you would always see the Earth at the same position in the sky. So you go outside of your lunar house and you see the Earth right here, it's always going to be there. You'll see the Earth going through phases, but it'll always be the same part in the sky. And the idea is that eventually the moon might get far enough away from the Earth that the Earth gets tidally locked to the moon. They're tidally locked to each other. And in that case, the moon would be very far away. It would always be at the same point in the sky. So if wherever you live, maybe the moon is always up here, or maybe on half of the Earth, you never see the moon at all. But astronomers predict that's not going to happen for about 50 billion years. And by that time, the sun will have run out of fuel and expanded and destroyed the Earth. So it's probably never really going to happen that way. But in theory, that would happen. So it's kind of interesting that they would become tidally locked to each other. But probably not in real life.
So the moon would never depart from its orbit, it would just get farther and farther.
Yeah, and eventually it'll get tidally locked to the Earth. So the Earth is always showing the same side to the moon. The moon's always showing the same side to the Earth. Then the moon's not receding anymore. And there are no more tides. There's no more tidal friction, and there's just kind of a stable situation. But it's expected that before that happens, in about 5 billion years, the sun is going to run out of fuel. It'll expand into a red giant, and it's expected the surface of the red giant will be about where we are right now. And so we'll be inside the sun. They're still not entirely sure about that. The Earth may spiral out of its orbit a bit when you get saved, but yeah. In the back?
In the solar system, we know like some planets have like more than one moon. Is there like any chance that we should Earth is going to get two moons?
For us to get 2 moons, something really extraordinary would have to happen, like interstellar comet would have to come through and smash into the moon, or something, something strange like that would have to happen for that to take place. Otherwise, our solar system is kind of a done deal. I don't think it's there are discussions from time to time about the stability of the solar system and whether it's always going to be kind of where it is. And it may be that over the course of billions of years that things move around and it's not perfectly stable. But that's something people in celestial mechanics study, and I don't know if they've ever come to a final answer about the stability of the solar system or not. It's just still people are doing computer simulations on it.
Someone in the chat also asked, is there an effect of sun gravity and earth gravity on the moon during the total eclipse?
No, in terms of gravity, it's really no different from any other new moon. So it happens to be that the sun and the earth and the moon are kind of in a straight line, but other than that, there's no difference in gravity. Because it's a new moon, there are going to be tides associated with it, but nothing unusual. Anything else in the chat room?
No, not right now.
Yes.
What would you say is like the big difference between the eclipse we had in 2017 versus the one that happened?
Well, the eclipse path was different. I think we saw the eclipse path this time. The one before, in 2017, I think that started up in the northwest and kind of went down this way. And there was some spot here where they crossed exactly in the middle. Some guy had his farm out there, and he was always having people stop by his farm. And they wanted to stand in the spot where there were going to be two eclipses, or both eclipses were going to overlap. And he was used to people driving by and they'd see his farm, and they were like, here it is. I haven't checked the calculation to see how big the moon was during the 2017 eclipse. But it couldn't have been too much bigger than what we're going to see next week, because that's about as big as it gets. It means the longest duration of totality in the center of the eclipse zone. And by the way, if you want to be in the center of the eclipse zone to get the maximum time for the eclipse. If you're on the edge, then you just get a few seconds of the eclipse. It'll be total, but not for very long. It'll be the longest in the middle of the eclipse zone. So I'm gonna map out exactly where I want to be when that happens.
What states are like more often to get an eclipse?
I don't know if there are any more or less often, other than the area effect. You're more likely to get an eclipse in Texas than you are in Rhode Island. So there's that kind of bias because of the size of the states. But in terms of the area, I don't know if there's really any preferred place to be. I don't know the answer to that. Yes.
Is there any area in Maryland where we can have a budget or to look at it? Because you said you had equipment to look at it when you're doing it.
Yeah, I don't know about renting it. I would, if you don't have anything, I'd use the eclipse glasses available up here, or just use some pinhole equipment. I don't know if they still make that sun spotter thing, but that's pretty. That worked pretty well. I took that with me to Tennessee. I could drive there, and so I could take a bunch of equipment with me. But I'm going to have to take a plane down to San Antonio, so I'm going to be limited in what I can take down there. Yeah, I don't know about any place that rents things. I would just make something that would work better. Any more questions or questions online? More?
How far out can we predict,
Usually people do predictions out several hundred years, maybe 200 years, 300 years ahead. So beyond that, our knowledge of events and celestial mechanics that tends to break down the longer you
I think you're hooked up to audio.
don't know about gravitational constants and things like that to be able to do predictions much more than a few hundred years in the future. And that includes celestial mechanics in general. We can't really predict too much in the future.
It's safe to look at the solar eclipse in an area that has heavy cloud coverage without special glasses.
I'm sorry, what was that, Dad? My dad.
Is it safe to look at the solar eclipse in an area where there is heavy cloud cover without special glasses?
That's my dad calling from North Carolina. Yeah, that's a good question. Yeah, it seems like if you've got heavy cloud cover, you could look, that would filter out the sun because, you can see the disk of the sun through the clouds. I wouldn't depend on that being 100% safe, but it may be. That's a good question. I I don't know if I'm qualified to give an answer to that. He's asking if you could look through a heavy cloud cover. If you've got heavy cloud cover and you can see the disk of the sun through the clouds, is that safe to look at? You know, maybe for short periods of time, I still wouldn't stare at it. Even through the clouds, because you don't know what kind of invisible light, infrared or ultraviolet is being blocked or not blocked. Thanks, Dad.
I think that's all we have for today. To give Dr. Simpson another round of applause, please. Thank you all for coming. Don't forget to grab some solar eclipse glasses and have a nice weekend.
One of the presentations, I was not a